Beta is a measure of risk that comes out of the CAPM model. In this module, we're going to discuss beta, discuss its interpretation, view it in the equations that used to calculate beta, and then we're going to discuss how you calculate beta from data. This is the security market line that results from CAPM, and it relates the expected returns on an asset to the risk-free rate and the expected return on the market portfolio. Again, and you see this relationship given in this equation, the expected return on an asset, any asset RA, which is on the left-hand side of the equation, equals a risk-free rate plus beta, and again, beta is the measure of risk, times the difference between the expected return on the market minus the risk-free rate. So what you have here is a linear relationship between the market portfolio, expected returns on the market portfolio, and the expected returns on the asset, and beta, again, measure of risk, gives or aids in determining that relationship between market portfolio returns and the returns on that asset. Beta has the following interpretation. Beta equal to 1 means that an asset, and beta will be specific to the asset, contributes the same risk as the market. So an asset with a beta equal 1 contributes the same risk as the market portfolio. Those that have beta less than 1 will contribute less risk, and those that have beta greater than 1 will contribute more risk. Obviously, as given the capital asset pricing model equation or the security market line, we would expect those assets that have higher beta to also have higher expected returns. Let's take an example. Let's say the risk-free rate is 5% and the expected return on the market portfolio is 9%. An asset has a beta equal 1, we can calculate its expected return. And again, that's given by the security market line or the capital asset pricing line, market line. We have a 5% rate of return on our risk-free asset plus 1 times the difference between the market portfolio expected return and the risk-free rate, or 4%. This asset would have a expected return equal to 9%. The same as, in this case, the expected return on the market, because again, that portfolio or that asset contributes the same amount of risk to that portfolio as does the market portfolio. Here are 2 additional examples with the same risk-free rate of 5% and the same expected return on the market portfolio of 9%. Here we have a beta equals 1.5 and also a beta equals 0.5. So the beta equals 1.5 is to the left-hand side at the bottom of the screen. Beta equals 0.5 is to the right. We calculate expected return for those 2 assets. The one with 1.5 has an 11% expected return. The asset with a beta equal to 0.5 has an expected return of 0.07 or 7%. Again, what you see here is for lower beta, lower expected returns, higher beta, higher expected returns. Again, beta is a measure of the contribution of that asset to the riskiness of a portfolio. So market portfolio. So beta equals 0.5 means that that asset contributes relatively less to that risk, 1.5 relatively more. The formula for calculating beta is given here. Beta for an asset equals the correlation between the asset and the market portfolio times the standard deviation of the asset divided by the standard deviation of the market portfolio. Again, you can see the derivation of this formula in a couple of the references in the previous module, but again, beta equals the correlation between asset A, or the asset itself, and the market portfolio, standard deviation of the returns from that asset divided by the standard deviation of the returns from the market portfolio. One other note about this calculation of beta is that you'll see that it differs from the definition given on page 177 of the text. The above definition is correct, and use this definition as you calculate beta. When calculating beta, note that the correlation coefficient of asset returns to the market portfolio will always be less than or equal to 1. That's by definition. Correlation coefficients has to range between -1 and 1, so we know that the correlation coefficient has to be less than or equal to 1, and it will almost always be less than 1. What that then implies is point 2 here, the standard deviation of the asset can be the same as the market portfolio. Let's say they're both 20%. That asset will have a beta less than 1, or given that the correlation coefficient is less than 1, which means that that asset contributes less risk to that market portfolio when you measure it in the relative sense. Note that the two interpretations here between the portfolio model and beta model differ. Portfolio model would say that if an asset and market portfolio have the same risk, they have the same risk, whereas the beta model would say that the correlation between the market and the asset is important in measuring that risk. Also note point number 3 here, as the correlation coefficient becomes less, the standard deviation of the asset can become greater, and the market portfolio and the beta will still be less than 1, i.e. correlation coefficient counters high standard deviations when looking at risk from a CAPM standpoint. Let's take the case of beta equal 1, i.e. the asset has the same market risk or contributes the same risk as the market portfolio. If beta equals 1 and the correlation coefficient equals 1, then the standard deviation of the asset has to equal the standard deviation of the market portfolio. If correlation coefficient is less than 1, then the standard deviation of the asset can be greater than the standard deviation of the market portfolio, and that relationship is given by 1 divided by the correlation coefficient. So if we take an example of correlation coefficient of 0.5 and we have a beta equal 1, then the standard deviation of the asset is 2 times the market portfolio. This slide shows relationship between the asset standard deviation divided by the asset or the market standard deviation, that's given on the vertical axis, and the correlation coefficient, which is given on the horizontal axis. Red line gives that relationship for beta equal 1, blue line gives it for beta equal 0.5, and green line gives it for beta equals 2. As you can see here, as the correlation coefficient ranges from 0, we can have very high ratios of standard deviation to standard deviation, particularly for betas above 1. And as that correlation coefficient gets closer to 1, the ratio of asset standard deviation to market standard deviation declines.